All right, remote-only calculus students, what you're going to miss on our in-person class today, this nice fancy red Wednesday, we're just going to do some whiteboard practice and summarize some derivative rules. You got some other things that you can do on your own that you're going to have to pause this, maybe go do it and pop back in. So the first thing we're going to do is we're going to find the derivative of a couple functions. So I'm going to write a function. You are going to pause the video, write the derivative of the function, and then I will write down the actual answer. So we're going to start with 3x to the 6th plus 2x to the 4th plus 3. So pause the video. All right, should have your derivative. This is the actual answer. It is 18x to the 5th plus 8x cubed. All right, and try another one. F of x equals 1/3 x to the 4th minus 3x squared. So pause the video. Video's on pause. This should be your answer. The derivative should be 4/3 x cubed minus 6x. All right, I'm going to put a couple on here, and you're going to do those. And they're a little shorter ones. So we're just going to do 4x and a separate function, f of x equals 7. So take a second, pause it, give these two a go. All right, your derivative for 4x is just 4, and the derivative of a constant is 0. So something to be careful of. All right, now I'm going to throw some insanity at you. So what if f of x is 1 over x squared? Or what if f of x is like the cubed root of x? So I'm not going to make these any more insanely complicated, but there you go, there's two. I will tell you right now, the first thing you want to do is rewrite both of these, and you want to rewrite them so it's in any exponent in the bottom is written as a negative, and any radical or root is written as a fractional or rational exponent. So now see if you can figure out what the derivative of these would be. Go ahead and pause the video. All right, hopefully you had a second to try these. The derivative of this would be negative 2x to the negative 3rd power, or negative 2 over x cubed. And the derivative of this would be 1/3 x to the negative 2/3 power, which is the same as saying 1 over 3 to the cubed root of x squared. So there you go, there's a couple there maybe that you could give a shot. And we basically did the power rule, which applies no matter what the power is. So here are a couple more to try. I'm going to extend these out a little bit, which just means I'm going to write them a little bit more extensive than the ones I just gave you. So let's see. Here's a good one. This will just test your boundaries. 7x cubed plus 3x squared plus x to the 3/5 minus 7 over x squared plus 2. All right, so these are all doing the exact same rule in terms of, we call it the power rule. And if you didn't notice what's happening every single time, and we will talk about this more, is this thing, the exponent, well actually let me go back to these because these are more reasonable. The exponent of 6 drops in front, has to be multiplied by what's there, and I drop that exponent by 1, boom. Exponent drops in front, gets multiplied by what's there, reduce that by 1. Remember, every time we graphed a derivative of a polynomial, it was a 1 degree less polynomial, and that's what's happening when we do that. So it doesn't matter if I put fractions in front, and this is a polynomial also. The power here is 1, and when I reduce that power, it becomes x to the 0, which is anything to the 0 power is 1. This is a power of x to the 0, so I can't actually, if I drop that power in front, it's just gone, it's wiped out. So that's why those happen. Same with this. That's why it's important to write it like this. That drops in front, reduced by 1. That's why it became a negative 3. Same with this. 1/3 drops in front. If I reduce this by 1, if I subtract 1, I get negative 2/3. Imagine doing these two with the limit definition of a derivative. But that's why the radical ones had answers that ended up with things in the denominator. All right, I skipped a page apparently. All right, So now you've had time to check it. Give these two a go. Pause it and try them. And the first thing I would do on this is I would rewrite it to negative minus 4x to the negative 2, so that the derivative would be, and here's the catch, it would be 8x to the negative 3, or 8 over x cubed. And this might have tripped you up, but that's a constant. The derivative of 2 is just 0, so I don't need to write anything. That drops in front, becomes a positive, reduced by 1 underneath. All right, this is the last one. Again, this thing I would rewrite as minus 7 to the x to the negative 2, so that I don't get anything mixed up. This is already the way I want it. It's not in a radical form. So if I go to find the derivative of this, it should be 21x squared plus 6x plus 3/5 x. And if I subtract 1 from this, I would have negative 2/5. Put that in front, I'd get plus 14x to the negative 3. Constant, derivative is 0. I don't do anything with it. And again, if I had room, I'd rewrite these to pop underneath. All right, that's pretty good for now. I'm going to go over here. And there is a there's a Desmos activity for you to do that will help you identify which two functions are derivatives of themselves. So I want you to take a second, go do those two things, and then you'll notice on this form as I scroll down, we already know the power rule, but we're going to abbreviate it. We've already seen this pattern with trigs, but we're going to write it down. And then the exponential one you will get from a Desmos activity, and this one you're going to be the missing one, and you're going to go to Desmos, just regular graphing. You're going to type in f of x equals ln of x, and then underneath that in a separate bar you're going to type in f prime of x, and it'll automatically graph the derivative, and your job is to try to figure out what function f prime of x equals, and you can type in other things underneath it to see if they match and fit. So go do all of those, and so pause this video, go do those things, and then come back, and we will have answers for you here. So pause it, go do those, and come back. All right, hopefully you really did what you were supposed to. Two functions that are derivatives of themselves would be f of x equals 0, and I'll use a different letter, g of x equals e to the x. And you would have found those out on that Desmos activity. So the general power rule, again, this is just a constant out in front. That n is going to drop in front, so it's going to become n times a x to the n minus 1, because we always reduce that power by 1. This is from that pattern when we graphed sine, and the derivative of sine was cosine, and the derivative of cosine was negative sine. Graphically, it was just the sine graph reflected over the x-axis, and then the derivative of negative sine would be negative cosine x, and then the derivative of that would put you back here. So really, these two are the ones to know. Derivative of sine, and then the derivative of cosine helps you out. All right, we already know this. The derivative of e to the x is e to the x. And it's important to know that if I have some other base than e, so if I had 2 to the x, its derivative is also 2 to the x, but it has a constant, and that's ln of 2. This also has a constant. It's ln of e, but the ln of e just equals 1, so we never write it here, so we don't need to. So that throws a little extra curveball. And you should have experienced ln of x, and if you played around with it, remember that the domain restriction for the log is that this has to be greater than 0. And so when you look at the derivative of this, it's really only half of the actual function that we're familiar with, but that's because we have a domain restriction, and that is that the derivative of ln of x is 1 over x, which was a graph that looked like this, but this piece of it doesn't count because I'm only interested in the positive domains. And again, just like any other base, if this is base 5 or base 10 or base 2, it's still 1 over x, there it is, but the ln of the base ends up right there, just like it would down here, ln of e, but ln of e is 1, so we don't write it. All right, there you go. That's your helpful hints for the day. I hope that helped. Bye.